and welcome to Physics 11, Projectiles, Lesson 1, Adding Vectors. Today we're going to look at what to do when we have two vectors and we need to add them together. Our first problem is our simple case. How do we add two vectors that have the same direction? In this case, this is a very easy question. We know somebody walks 25 meters north and then they walk another 13 meters north. Their total displacement is simply 25 plus 13, which gives us 38 meters north. Another way to do this question is by an arrow diagram. An arrow diagram is when you draw vectors as arrows that point in the direction where the length of the arrow corresponds to the size of that vector. So here in this example, another way to write 25 meters north plus 13 meters north is to draw a vector pointing north that is equal to 25 meters plus a smaller vector that is also pointing north equal to 13 meters. When we add these two vectors together, we see if we add 25 meter vector and a 13 meter vector on top, our total answer starts from the very beginning, goes to the very end. 25 plus 13 is 38 meters north. This is very simple, but this idea is what allows us to solve more complicated vector problems. Now, let's look at a level 1.5 problem. The same difficulty, but with one tiny extra step. Here, in this question, we have 25 meters north plus 13 meters south. With vectors, you can only add them simply algebraically if the directions are the same. But in this situation, south can easily be switched to north. Remember, south is the same as negative north. So we can rewrite this question as 25 meters north plus negative 13 meters north, which is the same as writing 25 meters north minus 13 meters north. And this will give us 12 meters north. Again, a very simple question, but this builds the foundations to our later, more complex vector problems. Here, as before, we can draw a vector diagram. Vector diagrams do not care about the direction of your vector, so we do not have to change 13 meters south into 13 north. We can simply rewrite this as 25 meters north plus 13 meters south and add the two vectors together. Here, if we combine these two arrows, we have 25 meters moving up, and then we will have 13 meters moving back down. Our resulting vector from the very beginning to the very end will be this difference between 25 and 13. So here our total is 25 minus our 13 gives us a final answer of 12 meters north. This red dotted arrow that is the answer of our problem is called the resultant vector. This word resultant comes from the word result, which also means the answer. So another way to say this is the answer vector. In physics, we will call this the resultant vector. So remember, from here, we can only add vectors if the directions are the same way or exactly opposite. If our directions are exactly opposite, we can switch one to the negative version so they match, and we can add our matching vectors. In fact, the rule is actually you can only add directions that are the same. If it's the opposite direction, the first step is to switch it so the directions match, and then you can add them or subtract them simply. But what happens if our directions don't line up? So now we're going to move up to vector addition level 2. What happens if our directions are unmatched? For example, you want to add 25 meters north plus 13 meters to the east. You may notice here, we cannot change east into north. Since east and north are perpendicular, they do not simply flip from one to the other with a minus sign. So we cannot use simple algebra to add these together. The only way we can do this is with an arrow diagram. We must draw our 25 meters north as an arrow of 25 meters length, plus our 13 meters to the east drawn towards the east. Don't forget your directions, north, east, south, and west. This is something that you are assumed to know at this point. Now here, adding these vectors together, we move 25 meters north, and then we move 13 meters towards the east. So this is 25, this is 13. We can now draw our resultant vector from the very beginning all the way to the very end. Whatever length this red arrow is will be the length of our final vector. But how do we solve this problem? Well, you may remember from Math 10 how to solve triangles with a 90-degree angle. Here, this is simply a right angle triangle with 25 and 13 as our two sides and our resultant vector as our hypotenuse. To solve this question, we simply use a squared plus b squared equals c squared, where a is 25, b is 13, and c is our resultant vector. Solving for our resultant vector, we find this is 25 squared plus 13 squared, and the magnitude of our vector is 28.18 meters. Remembering our sig figs, we find our answer is 28 meters. So the length of this red arrow is 28 meters. But we are not done. Here, this is a vector question. We must have a direction in our vector. To find our vector, we must use trigonometry yet again. Now here, we know that our direction is somewhere between north and east. But if we say northeast, everybody will assume it is perfectly 45 degrees out between north and east. So we need some kind of angle to show us how far from north or how far from east we are. The way that we can do that is by creating a triangle. Here, our triangle has a length of 25 and a side length of 13, with our resultant vector being 28.18. When you are working with these questions, if possible, try to avoid using this number, because this number is not perfectly 28.18. If we use 28 in our steps, we will be losing this 0.18, and our answer will be slightly different. Here, we should stick with 25 and 13, because these are directly from the question and they are perfect numbers. We want to find this angle because our arrow is moving towards the northeast, and this angle is at our base. You always want to find the angle that is at the base of your resultant vector. So remembering back to our Math 10, this is our opposite side, this is our adjacent side, and from SOHCAHTOA, we know we are using the tangent of the angle is equal to opposite over adjacent. Here, our opposite side is 13, our adjacent side is 25, and so our angle is equal to the arctan of 13 over 25, which is equal to 27 degrees. Therefore, our final vector is 28 meters, and for our direction, we have 27 degrees. This angle is starting from our north and then moving 27 degrees towards the east. So we say this is north 27 degrees east. In this situation, there is actually another right answer. If you drew your picture with the 13 first and the 25 after, your angle would actually be in here. In that case, you would find your answer is 28 meters east because you started from east and then you moved 63 degrees towards the north. Both of these answers are actually equally correct, and either answer is perfectly acceptable. There is no difference between starting from north and moving 27 degrees to the east and starting from east and moving 63 degrees to the north. Your final direction will actually both point you in the same way. From this example, we can create some general rules about how we can add vectors. In general, when we add vectors, we must use arrow diagrams. If we are lucky and the vectors point in the same direction, we can use simple algebra. But most of the time, they will not be pointing together in the same direction, and you have to use arrow diagrams. Even if they are pointing in the same direction, you can still use an arrow diagram. There are 5 simple steps whenever you add vectors using arrow diagrams. First, and most importantly, you must define your directions. Whichever direction you are using in your question, you must show somewhere in your work which way your arrows are pointing. After you have defined your directions, you will draw the first vector in your vector space. Or in other words, you will write down your first arrow in your paper. After you draw your first vector, you must add your other vectors. So then you will add your other vectors from tip to tail. It is very important that you add your vectors from tip to tail. In other words, you must connect the end of the first arrow to the beginning of the next arrow. Specifically speaking, if this is your arrow, then this end of the arrow is your tip, and this end of your arrow is your tail. So if you are starting with this red arrow, a second arrow must be connected like this. Once we have combined all our vectors, adding from tip to tail, our next step is to draw the resultant vector and solve for it using geometry. To draw the resultant vector, you will start from the beginning of the first arrow and move to the end of your last arrow. Make sure you point the arrow towards the end, because this will ensure you have the right angle for finding your direction. Speaking of the angle, the last step is to find the angle of the resultant vector and add your direction. Now that we know the basic steps for how to add vectors, let's try our first level 2.5 question. What is 44 meters north minus 13 meters east? In this question, you may notice a small difference. Here, instead of adding these two vectors, in this question, notice that we have a minus 13 meters east. With arrow diagrams, we can only add vectors. So our first step will be to convert our minus into a positive. To do that, we will rewrite our 13 meters east as negative 13 meters west. This way, our two negative signs will cancel each other out and become a plus 13 meters west. Now we can add these vectors using arrow diagrams. First, we must define our directions. Here, for this page, up will be north, right will be east, down is south, and left is west, just like with regular maps. Second, we will draw our first vector in our vector space. Our vector space is simply just the area that we are doing our work. So we are going to add our first vector, 44 meters north, given as our red line. Next, we will add our other vectors from tip to tail. So the tip of our first vector becomes the tail of our second vector, and we will add 13 meters towards the west. Then we will draw our resultant vector, and we will solve using geometry. Here we can see that the length of our resultant vector is equal to our first vector squared plus our second vector squared. So simply, our answer C is equal to the square root of 44 squared plus 13 squared. Here, using our calculator, we find that our answer is 45.88 meters. Now, for our last step, we want to find the angle of our resultant vector and add a direction. Here, the base of our vector is down here at the bottom, so we are finding this angle at the bottom. Here, our 13 is our opposite, our 44 is our adjacent, so we are using the tangent, and the tan of theta is equal to our opposite side over the adjacent side. Therefore, our theta is equal to the arctan of 13 over 44. Putting these numbers into an equation, putting this into your calculator, you'll find that the angle you need is 16.46 degrees, or just 16 degrees. Here, to get our resultant vector, we started from north, then moved 16 degrees over to the west. So our direction will be north 16 degrees west. Therefore, putting everything together, our final answer is 46 meters north 16 degrees west. Our last question is the same difficulty, it is just longer, but the question remains the same, and the steps you follow are the same. First, we're going to check to make sure everything is positive, because we can only add vectors, we cannot subtract them. All four vectors are positive vectors, so we can carry on and use arrow diagrams. Our first step is to define our direction. Here, we're going to say up is north, and we have east, south, and west, just as normal. Our second step is to draw the first vector in our vector space. Our first vector is 15 meters to the north. Next, we're going to add all our other vectors from tip to tail. So we have 12 meters to the east, we have 7 meters south, and we have 3 meters to the east. Next, we will draw our resultant vector from the very beginning to the end of our last vector. Now, using geometry, we will solve for our resultant vector. Here, we can see that the x component of our resultant vector is simply 12 plus 3, and we get 15 as our x component. The y component of our vector is simply 15 minus 7, which gives us 8 meters. So our two sides are 15 meters and 8 meters. Using trigonometry, we can find that our resultant vector is equal to the square root of 15 squared plus 8 squared, and we know this is equal to 17. Here in this triangle, we can use this angle as our reference, and we will have our tan theta is equal to 8 over 15, or theta is equal to arctan of 8 over 15, which is equal to 28 degrees. So in this case, our final answer is 17 meters. Here, we are starting from east and then moving up towards north 28 degrees. So this direction is east, 28 degrees north. Similarly, you can also say that this is starting from north and moving down 62 degrees. So another answer that is possible is 17 meters north, 62 degrees east. Both of these answers are actually correct. That's all for adding vectors. Thank you for watching.